No matter how well I will tell them. So means to solve this kind of queries, we should arrange one summer school. And that means summer school means what? It will be 8 hours per day, 4 hours theoretical part and 4 hours hands-on experience. So if it is likewise, these queries will be clear. Yes, Vibhakar sir.
You can start the session, sir.
Yeah. So I have shared some codes and one Excel file already in WhatsApp group. Hope everyone got that. Is it?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Okay.
Yeah. So first one will start with one short thing, that is normalization. Dr. Saurabh or I don't know who asked. I don't know whether she is there or not. So first we will start with the normalization of data. So just open that, download that Excel file and code file. So now can anyone tell me what is exactly the meaning of normalization? Yes. Can anyone tell me what is the meaning of normalization? So normalization is nothing but a process of organizing data to reduce the redundancy or to reduce the error and to improve the data integrity. So first I will show how to run the commands, and after completion just you can do, and then you can ask if any error will there or what. Just let me just see the screen first. So see, today there is one change in the file because today we will do the blob analysis and Eberhardt and Russell model. So in that, so this everything is same. That is first is environment, genotype, replication, first three column and 5 characters are there. So just I reduce the data set file. But here you can see, if you remember, for AMI model, we arrange the data set like total first replication, then second then second, then third. But here we arrange like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so just we will save this file as it is already in desktop. Then we'll go to R Studio. First, we'll import the data set. Then we'll set the working directory. So now after that, just we'll open the code. Just we'll copy this first code. So now here you can see we are giving one command to the software to normalize the data. So here see, first command is to normalize the first character. Here only 3 I have shown. So you can increase up. So you can increase up to 5. So just see C1 normalize the scale, and just you have to give that stability is the file name and say first thread. Similarly for C2, stability C2, C3, stability C3. So likewise, then just we'll see the normalized data. So here you can see the C1, C2, C3 normalized data is there. So now after this, we'll go for visualization of this data. First, we'll copy this C1. So here you can see. So this 2 and 3 means we are saying that arrange the plots in 2x3 grid. Then again histogram, stability C1, stability file name, character is C1. Likewise, if you press enter, you will get the 2 types of histograms. This left hand side is original data and right hand side is normalized data. So likewise, this
Excuse me, sir. Hello, sir.
Yeah.
Sorry
Sir,
to
there is
interrupt.
no data in the normalized text file.
Same,
Like,
sir.
there is
I
no.
also
Yes,
didn't
sir.
get any.
Normalization of data text file is there.
Sir, yes, sir. There
There are
is
no
no
codes
code
in that.
there.
So text file is there, but text file is empty. There is no codes in the text file.
How? Wait, I will reshare again.
Same here.
Yeah, now you can see why it is not coming. Wait, something is there. Now it came, huh?
No, sir.
Also, I do not.
No, sir.
No, sir.
What is happening? So just can you open the remaining text file?
सर उन दोनों में है पर इसमें नहीं आया, अभी भी नहीं आया सर मेरे पास तो।
I don't know, because in that file that codes are there. Here you can see.
So you better copy that
Sir,
and
get the
paste it
codes
in
in
chat box.
that box. Yes, sir.
सर तुम्ही फाईल जी शेअर करतायत त्याची साईज 0 KB दाखवतंय.
सर व्हाट्सएप पे भी कर दीजिए प्लीज.
Sir, only share on WhatsApp, sir. the
Yes, sir,
data.
in WhatsApp.
We can copy on the notepad.
So it's similar like C1. Just copy it for C2 and C3 and paste it. So like this, histograms will be there for normalization. So now just you can try, if any error is there, let me know. So up to this, it's fine. Yes.
So can you show your R Studio window?
Yeah. Just let me know after completion. Done?
Doing, sir, just wait for a minute.
Madam, your voice is not clear. Just let me know. We will proceed for blub analysis.
So show your R Studio please once.
Yes. See this. Yeah. Okay. So now we'll proceed with BLUP analysis, stability using BLUP model. So for that, we will use the same data file with name stability, but the codes will be different. So just this one by one code I will run. So anyone is pending with this normalization?
Yes, sir.
Hello, sir.
Yes.
Sir, can you please explain it again? The plot of normalization.
See, sir. So for what normalization means what? It will increase the data integrity. What exactly normalization means? It will increase the data integrity and it will reduce the redundancy present in the data. So here you can see this is our data set with 5 characters and their observations. So simply here to normalize the data in RStudio, we use this first command. So here directly we told to software to normalize the data for these 3 characters, that is C1, C2 and C3. This all the 3 characters are located in the file name stability. So after running this command, it will complete the normalization, and here we can see the normalized value for C1, C2 and C3. So after that, we got this normalization values, and after that we will go for the visualization of this normalized values. So after running these commands, we will get histograms. We'll get histograms for normal values of C1 and normalized values of C1. Similarly for C2 and similarly for C3. So this type of histogram will come.
Okay, sir.
सर C4 C5 क्यों छोड़ दिया हमने?
And no problem, you can add up to C18, C20,
Likewise,
anything you can add.
Okay.
That is not a mandatory thing, just you need to give 2 or 3. You can give n number of characters. So after this, just you can open the BLUP analysis code file. So first I will run this one by one command. Before that, just open your chat box. You need to install this package, Bruce R. Directly from tools you can install and run the library for that command, for that package. Okay, just you can see here the screen. I will run one by one. And along with browser, just run library for Meton also. That will be useful for analysis of stability using BLUP. So here you can see, as I already told you, I will tell you again. So just if you can see this Excel file for AMI and GG by plot, we arrange the data like 1, 1, 1, 1, first replication, then second replication, then third replication for AMI and GG environment wise. But here, what we did, we arranged the data replication wise. That is, in E1 genotype 1, 1, 2, 3. E2 genotype 1, 1, 2, 3. E3 genotype 1, 1, 2, 3. So we arrange the data replication wise. Genotype 1, 3 replications, genotype 2, 3 replications. So likewise we arrange. That is the difference. So as the data file is already imported, so just have a look. After that you can try.
एक्सक्यूज मी सर
Yes.
सर पैकेज कौन सा बताया था आपने जो इंस्टॉल करना है?
चैट बॉक्स में दिया है मैंने, ब्रूस आर.
ओके सर.
Just you can see. So the double star headings I have given. So that means this first is analysis of single experiments. So that don't copy that double star. The double star is heading for that code. So here actually first is analysis of single experiment we ran. Then second is likelihood ratio for genotype effect. Third, here I estimated the variance component and genetic parameters. And at last, the predicted mean values. Then the next I will go for BLUP model for multi-environment or multi-location trials. So here we need to set the model. That is, ours is mixed model, file name is stability, environment, file name is stability, environment represented by capital ENV, genotype represented by capital GEN, application by capital REP. So here model setting is going on. So now we have set the mixed model for BLUP analysis.
Sir, I have one question.
Yes.
Sir, in a command, it is written analysis of single experiments using mixed model, and other is written for MET trials. Sir, what are these
So actually,
experiments using mixed model and MET trials?
I will come to your question first. Let me complete this.
Okay, sir.
Yeah, just remind me after completion, just remind me the question.
Okay, sir. Okay.
Then now it is the normality of random effect of genotype and interaction effect. Then now we'll go for printing of model outputs. That is, first one is likelihood ratio. Then second is here variance components and genetic parameters. Then blobs for the genotype. That is for ours is C1. For C1, we calculated the blobs. So now here, next is get model data. So as I have given here double stars, those the function get model data may be used to easily get the data from a model fitted with the function, especially when more than one variables are used. It will give the predicted, this code will give the predicted mean of each genotype. As we have considered the 5 characters, so it will give the predicted mean. Then we'll go for plotting of blob for genotype. So for that we need ggplot2 package. So as that day I have installed it, so I will run the library command. After that, I will copy. So here you can see the graphs. Now the next is blob for G into E combination for the thread C1. So it will come like 600 in numbers. So here, like your standard error, standard deviation, coefficient of variation, minimum, maximum, minimum environment, maximum environment, everything is there. Then after that, there is a one method called WAASB, WASB model. So total, how many models? AMI, GGE, then BLUB, and then this is WAAS WASB model. So same command is there, METAN, that is multi-environmental trials. So first, that roadmap is also same. So first we need to set the model. As in BLUB model, we use mix model. We set the mix model. So here, the model itself, it is WAASB model. So simply, and rest is same. File name envgenrep. Just the model name change. So just you can say here, these are all the principal components. This is the tier trade, and these all are the principal components, and these are the, like we saw yesterday, some stability parameters for AMI. These all are the stability parameters for this WAAS. Then we'll go for eigenvalues. Here in this case, in this data, eigenvalues are 0. Here you can see in this graph, as the values are 0, the graph is straight line. Then we'll go for the phenotypic mean. "50 genotypes, 4 environment." So this phenotypic mean of 200 total. So we'll go for biplot. So this so here you can see this biplot is trait C1 and PC1. That is a type 1 plot. So this type of biplot will come. Then the next is simultaneous selection for mean performance and stability. Those who are sending the queries, just have some patience. I will come to you. And then last is the remaining blob-based stability indexes. So here and then last is FAI, blob selection index. So in this other stability, we'll get the remaining stability parameters. And then at last, we'll get the genotypes. That is, you can see here total 50 genotypes are there, and which are selected and which are non-selected, everything it will give. That is a total blob. So now you can do the analysis and then we will discuss the questions. Meanwhile, I will solve the queries. Vaibhav. Hello, Vaibhav.
Yes, sir. Solve
Actually-
solve that problem.
Okay. So check your input file name and the name in the command. So as I have typed stability, so just check your input file name, whether it is stability or stability_1 or stability1. Yes, so number ending with 905. So madam, please install that Bruce R package and run the library.
Sir, I already did.
Run the library.
I did that also, sir.
And stability. So your input file name is correct, huh? And stability.
Yes, sir, I have changed it and after again deleting everything, I did again all this
So
process.
that
Still it is
underscore
showing the same.
that underscore is there in your input file name or what?
Sir, I have changed the name as stability, just like yours. Again, and I have kept the same problem it is showing to me.
Just once you
Hello,
can check that package is there or not. Bruce R package in right hand side package option.
Okay.
Hello, sir. Can you see the query number ending with
65,
8265?
yeah? Okay.
Yes, sir.
Madam, you have run that library meten command?
Yes, sir. Yes, sir. I've learned it.
ggplot?
Yes, sir.
It is coming error in train continuous. That is self-range. Just once you can try this total from VAS model starting.
Okay, sir. I will try it once.
Number ending with 4059. So you need to, number ending with 4059, you need to run the library commands for meten and Bruce R.
Sir, number ending with 8857. Can you just see the email? From there I'm getting error.
Sir, now what you said, sir, Metal and which library we have to run?
Bruce R, BRUC, that name is in chat box.
Okay,
Bruce
sir.
R, BRUCE and capital R. Same madam with you, number 8857. Install that package and run the library.
I already installed the package from the tools.
Then run the library.
Sir, it is like I'm getting error in inspecting. Like inspect.
For print, those who are getting the error in print table, just install the Bruce R package and run the library. your inspect command, no problem with that. You are facing error for print table, madam.
Yeah, and it after like installing Broussard, it is saying that it is already installed. Again, it's showing error.
So no. I am saying to run the library command.
Okay.
I am not saying to install it again. To run the library command for both the packages like Metan and Broussard. That is same for Raghavendra sir. Same that go for Broussard.
Yes, sir.
Hello, sir.
Yeah. Number ending with
Sir.
074.
Sir, number ending with 265. 65. I'm getting the error again and again, sir.
What is that error?
Excuse me, sir.
Yes, madam.
Can you show your R studio where we have done the block model for MET trials? That code
Block.
portion.
I will do it again. No problem. This one, no?
Yes, sir. The same error it is showing, sir.
So just type the file name again.
Okay, sir.
It will come.
Okay, sir.
Delete that file name and type it again. Though it is same, I think some
Sure,
glitch
sure.
is there. Yeah, that's what. If you are running that mix model of blob for MET, just delete that file name and type it again. So that is a database, something error is there. So if you will type again, it will run.
Yes, sir. Yes, sir, it ran.
Yeah. Same thing. Done, Vivek. Seven zero not 7 is 265.
Sir, screenshot, sir, last 7 4.
Same, delete that file name and type it again. That's what I'm saying. Some glitch is there.
Means, sir, after like erasing, deleting, we have to write it again, the stability thing.
Yeah, just type it again. Same thing, but just type it.
Okay, okay, sir. Sir, I have shared you one screenshot number ending with 157.
Same thing. Erase that file name and type it again.
Sir, that is stability, no?
Yeah, your input file name, erase it and type it again.
Okay, sir. Okay.
Okay. So anyone? So after completion, let me know. Then we will see the one by one either graph or table.
Completed, sir.
Completed, sir.
Excuse me, sir.
Yes, madam.
I have sent you one query 905 number, sir.
Same thing I'm saying. Just give me a minute.
Okay, sir.
Just can you show me that VASP model? This whatever I am highlighting. Can you show me that what happened after running this command?
Yes, sir.
Those
I'm
who are
showing.
getting the error.
सर आपको भेज दिया मैंने 905 नंबर से.
Sir, the number ending with 883. Sir, there is no any error, sir, in my. by
It will
using
depend on, it will be varied according to the system. Okay, so up to was model print up to print table it is correct.
Yes, sir.
And then now just to start from this, just show me these three commands.
So it has generated that 600 data file also.
In this table generated, no?
Yes, sir. And in the sir vast model, when I have kept that print table data, so that table has also come. PC1,
Okay.
PC2, PC3 values. Yes, sir. After that, the third command is there. That is not working. It is showing error in train continuous.
These three commands.
Yes, sir. In these three commands, the last line plot eigenvalue, that line is not working. It is showing some error.
So apart from these two, anyone got this type of error?
No, sir.
Sir, I have shared one screenshot, number ending with 157.
So number ending with 4059.
Yes, sir.
So check here as your file name is stability underscore 2. So just check that input file name and file name in command.
Both are same, sir. Still, I'm getting error.
Both libraries are there. Both Meton and Browser.
Yes, sir. I installed both.
Libraries I am saying.
Yes, sir. It's there.
Packages are there, no problem. But whether you run library command or not.
Yes, I ran before running this command, whole command, sir.
Just once run it again and just you can try.
Okay, sir.
So your GG plot 2 is there in your R Studio
Yes, sir.
library?
Yes, sir. All is there.
Yes, sir.
Exactly zero.
Sir, the number ending with 883, I share one image, sir.
Correct only.
Okay, sir. Sir, but in middle there is showing that VASP index was not computed, sir. One warning is showing, sir. Then
That's what I'm telling from day one. Don't listen the warning.
oh,
Only
okay, okay,
only listen to RTO warnings while driving.
okay, okay, sir. Okay, sir.
Sir, I have shared one image, number ending with 157.
That 1.7. Don't read that warning. You got that final graph,
Yes, sir, I got the graph.
then it's fine.
Okay, sir.
So don't worry about this number ending with 074. Now, as you gave command for data inspection, that's why this something is there. So don't just scroll it down and just go for the commands. Library Metan and library browser. Library Metan and library browser. So how many members completed up to that last graph? So just once see those two participants, those are getting this error. Just check your GG biplot in the right hand side package whether it is there with a click.
Yes, sir, it is there with the click. I already checked.
Because it is showing some issue with that package only.
Sir, I checked it at the time. It is the tick mark is there on GG plot.
GG plot or GG plot 2?
GG plot 2, sir.
So the same, huh?
Yes, sir.
Yes, sir,
Same
same.
problem is coming.
I will tell you this. So just you can proceed with the next one.
Sir, all the codes are running except that one bus.
Except that
Same.
plot.
Yes,
Yes, sir,
sir.
same here.
So anyone is there again with this error I will show you. Just if you can show that error in chat, just paste that error in chat box.
So there is no option of putting the error in chat box, the image.
No, just you can copy that from your R. So Nunavat, it is due to that you didn't run the library command. That's why these errors are coming.
Sir, I have pinned the error.
Yeah. Umil Singh Nunavat,
Yes, sir. Yes, sir.
you didn't run the library commands. That's why these things are coming.
Sorry, except this mix mode, remaining everything I got, sir, actually.
Yeah. Just they need library commands. Yeah, so this both of you, as you are saying already, you have GG biplot 2. Just install the package scales.
Okay, sir.
Just install along with ggplot2, install the package scales. After that,
Yes, sir, done.
just check this what I am sending in
Okay,
chat
sir.
box.
Okay, sir.
Okay.
Complete this bracket for the scales. The GG biplot version should be more than 3.5 and scales version should be more than 1.3.
Yes, sir, for GG plot 2, it is 1 second. It is 3.5.2.
Okay. After doing all this, just restart your R session. Then you can run those pending commands. You need to restart the R session.
Okay.
Yeah. The remaining people here you can see now. So here what we did is, first we did the inspection. We did the inspection of data. So inspection of data for what? Whether any missing values, to reduce the redundancy, as same as like normalization, this inspection is there. So you have to do, but no need of any interpretation or no need to include it anywhere. It is just a normal routine, just like our routine checkup. So now from here it will start. The first step is analysis of single experiments using mixed models. Yeah, someone raised those questions, that is mixed models and MET. Yeah, MET is nothing but your multi-location or multi-environmental trials. And as far as the models, there are two models. One is mixed model, then linear model. There are then mixed linear models. So there are various types of models are there. So here in this stability, we will use mixed model. So then this analysis of single experiments. So this is this code we run. So now here we got the p-values for likelihood ratio test. So here we got the values for genotype for the particular analyzed traits. So what we got? P-values of likelihood ratio test. So what is meant by likelihood ratio test? The p-value of likelihood ratio test, from this table we will come to know whether adding parameters to a model will significantly improve its fitness. So means we are testing genotype. So it is like, if we increase more number of parameters, can we fit that genotype into that particular environment? That is the meaning of this likelihood ratio test. So that means more number of parameters, if it is there, can we fit that particular genotype based on these values. So as this, you can read all variables with significant level. It is given a genotype effect. Then after that, here you can see we have total number of genotypes, that is 50. Then these are the average mean values. Then here it is minimum and maximum. Then minimum genotype, which genotype is having minimum for all the 5 traits and which genotype is having maximum value for all the 5 traits. So then next is likelihood ratio for genotypic effect or genotype effect. So this table is for likelihood ratio test for genotype effect. So here you can see these are our all 5 parameters. Then model is genotype. Then these are all the ratios we got all for all 5 characters. It is coming as a significant. So the next is our genetic parameters. So here it is. Genotypic variance, phenotypic variance, heritability, coefficient of variation. Character wise it will come. Then these are the predicted mean values. For all the total genotypes, for all the 5 characters.
Sir, what is CVG and CVR in the table?
Where, madam?
Sir, just above table, sir. Sir, below.
In this genetic parameter you are saying, na?
Yes, sir. CVG and CVR.
So these are, madam, this CVG means genotypic coefficient of variation. Generally, we will represent as a GCV.
Okay, sir. Okay.
Here it is represented as a CVG.
Okay, sir. Answer that CVR.
And this CVR is residual coefficient of variation.
Okay, sir.
It measures the relative amount of error. Whatever present in your data set, it represents the residual percentage or residual amount of variation.
Okay, sir. Answer that one H2NG.
That first H square is nothing but that broad sense heritability is there.
Yes, sir.
And next is broad sense heritability based on mean values.
Okay, sir. Okay.
That is formula is same. That is genotypic. Is normal heritability will calculate as a genotypic variance to phenotypic variance. And this H square mg we calculated as genotypic variance divided by phenotypic variance on mean basis.
Okay, sir. Okay.
So just the difference is on phenotypic variance. Yeah, so these are all are the predicted means for the 50 genotypes for all the 5 traits. So then after estimating that all these things, here we start with BLUP model. Then just you can see here. this type of scatter plots will come. Then if we have to see again this normality of random effect of genotype and its interaction, we can use this RE type. Like this. So here you can see in this first, it is only genotype. In second, it is genotype plus G into E. And in third, it is G into E. So that is the difference of these three types. First is only genotype. Second is genotype plus G into E. And third is G into E.
Sir, your voice is breaking, sir.
Sir, the screen is not showing and your voice is also not clear.
Your screen is not visible, sir.
Sir, your voice is not coming.
Yeah, sorry for the net interruption. Some issue is there. What an idea I am using. So disturbance is there. So now screen is clear.
Yes, sir.
Yes,
Sir.
sir.
Yeah.
Yes, sir.
So yeah, now you can see my R Studio.
Yes, sir.
Yes, sir.
Yes, sir.
Why it is clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what I was telling is, we estimated this likelihood test here. Here you can see. So this likelihood test we estimated only for genotypes. But now here, this likelihood test here you can see, we estimated for genotype and genotype into environment interaction. So here you can see this genotype environment interaction likelihood test is non-significant. And for genotype, it came as a significant. For that, for these 5 particular characters, if you will increase more, this result will vary.
Sir, I have one question.
Yes.
Sir, as genotypic and environment interaction is non-significant, so it means that there is no effect of environment.
No.
Only
I am saying just for likelihood test ratio. I'm not saying about total interpretation. Total difference you can see here only, madam. So here you will see in this middle graph, when we'll compare this blobs for G plus G into E and blobs for genotype. So in this second graph, you will see a lot of deviation as compared to the first.
Yes, sir.
So this is this graph. From this graphs, you can conclude for this particular trait.
Okay, sir.
Then again we'll go for variance parameters. Here, phenotypic variance, heritability. Again, this H2MG is there. That is heritability based on mean. Then CVR, CVG. Then some new words are there. That is GEI R square, RGE. So RGE, it is nothing but, you can say, our GAM. We used to represent GAM. So what is that GAM in genetic variability?
Genetic advanced mean.
Yeah. So RGE stands for genetic advance as a percent of mean. We used to represent like GAM. Here it is RGE. And here it is, just here this row is genotype environment interaction. Simply, as you can see on this third graph, it is a 0. That's why it is a straight line. So that's why it is 0 everywhere for all the 5 characters. And then now we'll calculate the blobs. So what is the full form of blobs?
Sir, best linear unbiased predictors.
Okay. So generally, it is a statistical method. It will predict the breeding value of a particular genotype in both way, like treatment, like genotype individual and genotype into environment. So in both way, it will predict the breeding value of that particular genotype. You can say breeding value, or you can say as a genetic potential of that particular genotype. That is nothing but your best linear unbiased predictors or prediction, whatever it is. And this bluff, as we started from mixed model, so that's why we are using bluff, because bluff is the statistical method oftenly used in mixed models. So then,
सर मिक्स मॉडल बोलने का मतलब क्या है?
so as there are number of models in analysis of our either field data or our molecular data also, like our marker data, like QTL mapping or GWAS. So actually mixed model is nothing but it includes two effects. That is, one is fixed effect and another one is random effect. That is systematic variation in data or random variation in data. In both ways, it will work.
Okay, sir.
So now fixed effect means what? This mixed model will include fixed and random effect. So fixed effect means your genotype or treatment. So see, if you will screen your material, breeding material, or you can say your hybrids, so your name of genotype or number of genotype will remain fixed. And that is your primary interest. For whatever the number of observations you will take, that your number of genotypes will be fixed. But when you will consider random effects, random effect means whatever the variation will create or whatever the variation will produce from the different sources, like your environment. If you have 50 genotypes, that all the 50 genotypes will differ with each other. So that is not a fix. One will differ with 5, 2 with 7, 5 with 10. So that is your random effect. And the most important random effect is environmental. So this is random sources, like random effect. Your genotypes are fixed, so it is fixed effect. So this total is called as mixed model. Hope you are getting it.
Okay, sir.
Yes, sir.
Yeah. So this, after calculating bluff, now we'll go for library ggplot2. Then we'll plot this. So here you can change these dimensions, as I already told you, according to your system or according to your need. Then calculation of bluffs for interaction. So how it came 600? Yes. The last number is 600. So how it came? We calculated bluffs for G into E interaction and total is 600. Anyone? Yes. So total number of genotypes are
So 50.
Total replication,
So 3.
50 into 3,
150.
150.
150. Total environment,
So 4.
4.
150 into 4.
Okay, sir, got it. 600.
Yeah. So now just see here, on your left hand side, tables are there, and on your right hand side, diagram is there. So here you can see the values for blob with genotype. Then in second column, you can compare the diagram and these values. Third diagram, blob for G into E. As in diagram, it is a stable horizontal line on 0. So here you can see all the values are 0 for all 600.
One
If you will
question,
increase, why 0?
sir, what does this red line and the dots around that line mean?
So
Matlab how I
actually it is like one constant. One constant, and according to that constant, the deviation of your data points, these black or dots are nothing but your data points.
Okay, sir.
Yeah. So here and then next you can see blob for G plus G into E. So accordingly, you will understand this from table and this diagram. What are the blobs for interaction effect? Then yeah, so here again, you will get the standard error, standard deviation, your CB, minimum, maximum, minimum genotype, maximum genotype, minimum, maximum environment, everything. So this is blub, and after that now, it is WAASB. So this is the fourth method, or you can say as a model for stability. So now what is this WAASB means what? So this WAASB means weighted average of the absolute score. Weighted average of the absolute score, which will consider all the principal components. Which will consider all the principal components. Whatever will be there from blobs. As we have estimated, and we will estimate it next, that is eigenvalues. So from that, it will consider everything, whatever the principal components will come. So first here we will set the model. So here again same. Earlier we got only genotype values. Now here genotype and G into E. So next, So all these species in this data set values are 0, but if you will increase the data or you will use any different data set, this result will fluctuate. Then here we go for eigenvalues. It will come 0 and the plot will come as a straight line as the values are 0. Then we'll go for phenotypic means. As this is for only for C1, so the phenotypic means are there. Then now we'll go for biplot. We need to adjust this window in this. Yeah. So as it is based on all the stability models base is AMI. So as these PC values are 0, all the genotypes you will see in one straight line. Then here, yes.
Can you repeat, sir?
Yeah. So here you can see, as we have got all values of all the 3 PCA values are 0. So that is the reason all the genotypes are there in one line. Here you can see. Then now next is simultaneous selection for mean performance and stability. So here just you can see. So here you can see all these are your genotypes. And then these all are your index, WAAS. And here it is showing red means from red to blue, from 0 to 100. I write this for the rankings are there. 46 is first one, 43, 4, 14, 45, 47. So likewise, ranking of genotypes are there. As we have calculated the simultaneous selection, so it gives directly the ranking of genotypes.
So ranking means it is showing only 48, 49. No? There are totally 100 genotypes are right now.
From where you got 100?
No, I mean to say in the bottom you get 100. What this refers? At the bottom,
So
0 to
this
100.
here, can you see on your left hand side genotypes on y-axis?
Yeah. Okay, 46.
Yeah. So all these are your genotypes.
Yeah.
If you remember, we use only 50 genotypes.
Okay.
And this 0 to 100, is a selection index based on your WAAS model. So
Okay.
what we did, we calculated the simultaneous selection index for all our 50 genotypes. So when we gave the command, so the output is, it will give ranking to different genotypes.
So WASBY means stands for, sir?
It is weighted average of absolute score, which will consider all the principal components of the blocks for G into E interaction effect obtained from mixed model.
Weight absolute.
I will drop in chat box.
Okay, please.
So then, with this command, other block-based stability indices, so whatever we have calculated, so remaining block indices we'll calculate with this. So here you will see that is HMGB, HMGBR, RPGB, RPGBY, RPGBR. So that is HMGB means harmonic mean of genotypic values or harmonic mean of blobs. You can write it as a HMB, harmonic value of blobs or genotypic value or genotype. In any way you can consider. Then RPGB, RPGB is relative performance of genotype. And the third one is HMRPGB. So it is harmonic mean of relative performance. It is harmonic mean of relative performance. So then here some are underscore R, underscore V, this RPG underscore Y. So these all are the parameters based on responsible for blood analysis. And this last is FAI blood in selection index. It is like factor analysis blood selection index. If we'll copy, if we'll paste it. So here it will give us the selection of genotypes. So here you can see the red one as first is saying the genotype number 14. Then second genotype number 2. Third one genotype number 9, 37, 36, 47, 5 and 8. So this much genotypes straight away it will give. So this is all about the bluff model. So after running this, here you will get, for factor bluff, you will get the five PCS with eigenvalues and cumulative variance. Then after that, this factor analysis for all the 5 traits. Then these all are the selection differential. And then after that, selected genotypes. So this much things this bluff will give.
Sir, I have
So
one
selection
question.
differential means what? So let
Hello,
me come.
sir.
Just give me 2 minutes.
Okay, sir. Okay.
Yeah. So selection differential means what? So selection differential is nothing but a difference. Whatever the genotypes we selected, in the performance of the selected genotypes and performance of the total genotype present in a population. So that is called as selection differential.
Sorry. Genetic gain of selection.
Yeah, you can say as a genetic gain. Yeah, so you can continue with your question.
Sir, you were reading the results and the short forms. Is there any study material to read these tables and everything in the R?
You will get everything on GitHub pages.
Okay, okay, sir. You have to refer GitHub.
Sir, can you send any review paper of that WASB and Blux model in WhatsApp group?
Yeah.
Thank you so much, sir.
Just better than WASP and this thing, just you can search for everyone, search the papers like integration of different stability models.
What, sir? Your
Integration
voice
of
is breaking, sir. Can you repeat, sir?
integration of different stability models in plant breeding. You will get paper, I think maybe on MDPI you will get. Mostly on MDPI, you will get the papers.
So integration of stable models, sir.
Integration of different stability models. Mostly this type of papers will be there in MDPA. I will share you one paper. So if anyone is having any question, meantime they can ask. Yes, I have shared one paper in group. It is coming. Now you can check. So like that papers you can search. That interpretation or anything. If any difficulty or anything, you can ping me. So most of you are there in my new group. So there also you can ask or you can share your thoughts. No problem. And for students, just go through the papers and don't compare these results with Windows Stat software. It will total difference will be there. In diagrammatic representations, in tables. Yeah, so anyone is having any questions, then they can ask.
Sir, if you can
Full
get
form. Yeah.
Sir, if you can get the recorded version of each day, we can go through it at the end of the presentation and then we can try on our
So
own.
actually, I discussed this with Bibakar sir. So Bibakar sir told at the end, as we are giving you one PDF file, with that PDF file will contain in short theory, then codes with example, and along with the videos. So this much he will share to each and every participant.
That's fine, sir. But as I personally feel that if we get the same video on the same day, we can go through it after the class and then we can try our own. That will be helpful for get recapturing. And at the after end of the 10th day, means it will be slightly difficult to go back
Yeah,
to
Bibakar sir. I will ask him to come online. Just give me 1 minute, Praveen sir.
Okay, sir.
Excuse me, sir.
Madam.
Sorry to disturb you, but
No, just ask.
Are you going to take any other topic after this?
Not today.
Not today, na? Sir, because I have an exam tomorrow, so I would prefer.
No problem, no problem. You can left. You can left that tomorrow we'll take.
Okay,
Sir,
thank you so much.
Hello. Bibakar sir. Yes, sir. Just Praveen sir, you can ask.
Bibakar sir, as
yeah, you can ask, sir.
Yeah, it's my personal opinion. It's not that everyone, because after the end of the class, if we can get the recorded version of the same day, we can go through it properly again at our free time, and then we can practice it. That will help us to get it properly, understand that day's presentation. If we get it after 10 days, automatically what will happen is we have to go back to second day, third day recall. That will not be so comfortable. I feel that it will be great if we can get the recorded version the same day and the same, then we can have a look and practice. That will be a great revision for it. That's what I feel. It is up to your management.
Bibakar sir.
Yes, sir. I am here to
whatever the query Praveen sir is raising, I think you can think of it.
Okay, sir. From the next program onwards, we will add update the videos daily?
Yeah, because what will happen now, no problem. I have dictated them for 2 hours, but when they will left the meeting, after 15 days, they will after 15 minutes they will start forgetting something, and at one place they will forget everything.
Exactly, it is a human mind. We can't capture it now.
Yeah.
Just what? Yeah, that is the
It is
practicality.
normal. It is a normal human mentality.
Exactly, sir. That's what I feel.
So I also feel just think on it and just update this.
And further, I'll abide with the decision. I'm just sharing my opinion, personal opinion.
No. I am also requesting him.
That's a
So
thanks a
he
lot.
can
That's a thanks.
he can.
Parveen sir, I am logging from the percent account, and from here I am saying from on the behalf of him, we will update daily videos from the next program as it finishes.
Thank you.
Yeah,
Thanks a lot.
thank
That
you.
is a great help.
Thank you, sir.
Thank you. Thank you, sir. Thanks for understanding.
Because positive and negative suggestions are always welcome, so that we can make much more better.
Exactly. That is it should be the ultimate aim of the training.
This
Thank
kind
you.
of
Thanks a lot.
this kind of inputs, this will
Will
only
help.
means we'll get only improvement from this kind of inputs.
Exactly, sir. True, sir.
Okay.
Okay.
Sir, I'm having one doubt, sir,
Yes,
regarding
madam.
check varieties. Sir, I
Yeah.
wanted to ask that suppose we are doing a trial, so we have to compare, suppose we are having 50 germplasm, so we have to compare
Okay.
this 50 germplasm with check varieties. So, sir,
Okay.
suppose we like I'm from suppose Bihar, sir. So if I am doing any trial in Bihar, so should is it necessary to take check varieties from Bihar, like regional check varieties, or we can take the national like release check varieties which are used by other states as a check variety?
So as per my opinion, madam, you should collect the check varieties across locations. It is not like a regional or national. You should make a core that should include your local also and across locations also. It will give you a better result.
Sir, if it is yes, sir, it is true that we should, like, if we are doing our work, so if we are collecting from Bihar as well as from other states, the national universal checks, that is better. It will be better in our results. But what if, sir, we are getting some and we are not getting the other? Suppose if I'm not getting the region specific high yielding variety, which I can use as a check, but I'm getting the national check. So can I use that, or it is mandatory that you have to?
No. It is not like that.
No, I feel if it will interrupt you slightly, Mr. Anuradha, I think the term national checks, it is better we take that where you are going to trial, that local genotype or whatever you want, that should be a great advantage, because the national check means you mean to say it should have a good adaptability throughout the nation. Then you can take that as national check. But if you're trialing in the south of
It
India,
is depend on your interest,
yeah.
research interest.
Yeah. So if you want to trial any hybrid, that should be promising in that prospective place than the throughout the India. So if your target, it depends on the target of your market. That's what I feel.
Whichever area you are targeting, if you are targeting local, then local. If you are targeting nationwide, so you should go for nationwide.
No, sir, it is not like that. Like, if since we have started our work, so actually, sir, we are not that much clear. So that's why I thought to ask sir, to get some information regarding that. Like everyone says that you should collect your region specific varieties, high yielding varieties like that, instead of collecting the national varieties, which is already released. But the thing is that if we are not getting regional specific, it is there, but if we are not able to collect, then sir, will it be a problem? Whether we should go for
Actually,
no.
Praveen sir gave a clear-cut statement that it is depend on your objective.
See, I will just tell you one thing, little bit. See, if you have a target to develop a hybrid, whatever, for particular region like south, north, east, west, you take that as the example. Then, if we get any hybrid which is performing throughout the India, that will be a great help for you. That you can consider the national check. But your main focus is on the particular segment or slot or a region which you have been asked to. That's what I feel.
Okay. Okay. Thank you, sir. Thank you, Praveen sir.
Sir, I have one
Good evening,
question, please, sir.
Honorable
Hello.
Yes, Shambhu.
Sir, I am asking about all the sir. Among all these models, sir, which one is better and which one has a greater efficiency all about?
So, see, nowadays, whatever the recent works are going on, mostly AMI and GG, both models are in use.
Okay, sir.
But now, if you will go through the recent publications, so AMI, GG, and BLUP. So all three will include all three.
Okay, sir. That means the AMI, GG, and BLUP is greater than all the above. Thank you, sir.
Sir, good evening, sir.
Yes, Vinod, sir.
Sir, I am Vinod from actually I am working in JK Paper Limited in Odisha.
Yeah.
Sir, actually I am using only eucalyptus and casuarina. We are every time calculating on productivity, sir. Productivity. That is two traits. One is height, another one is girth.
Yeah.
This is enough for me. So, what are the statistics tools for very essential to me, sir?
What is your objective?
Objective getting productivity, sir.
So means just
Selection of good genotypes for
just
good
from your
productivity.
experiment, you are selecting the varieties which are having high productivity.
Yes, sir, high productivity.
So just you can compare with the standard varieties and you can select by doing basic analysis.
Basic.
Whichever the design you are using, so just you can analyze with the design. You can analyze and by comparing you can select.
Yes, sir.
Okay. So tomorrow we will come at 6, not 6:50. Tomorrow's session will start at 6. And apart from genome-wide association
On
and
which topic,
QTL
sir?
mapping, huh?
On tomorrow, on which topic, sir?
Yeah, that's what I'm coming. So apart from genome-wide association and QTL mapping, we will try to cover everything. That is heterosis combining ability and your cluster.
Thank you, sir.
And then last 2 days, purely we will see genome-wide association and QTL mapping.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay. Thank you. Tomorrow we will see that
Thank you so much, sir.
clusters, matrices, and combining abilities. Okay, thank you everyone.